Good morning, everybody. Welcome to this BDVe webinar series. As you know, artificial intelligence is a hot topic today, and in particular, the use of deep learning is becoming more and more important. Today, we have the pleasure of having with us one speaker who is going to present an overview of the work done in the scope of the DEEP-HybridDataCloud project, presenting us their approach. But before that, please allow me to say a few words about this particular webinar series. This webinar is part of a series where we are inviting speakers from different organizations and projects to talk about their expertise, their experience working with big data and artificial intelligence. In case you believe that you have, by the way, a topic of interest or would like to be a speaker in one of our webinars, please don't hesitate to contact me, and I take this opportunity to invite you to send me an email anytime. The goal of this series of webinars is to show the value of big data and artificial intelligence from the two sides, the technical and the business sides. And as well as touching some interesting topics for our community, things such as lessons learned, best practices, innovative solutions, societal challenges and debates, etc., etc. We run at least one webinar per month, typically on Tuesdays at this same time at 12. But stay tuned, as the schedule depends, of course, in the context, such as the ability of speakers, or try to avoid coinciding with related events. So the schedule is not always on Tuesdays. We will run these 3 new webinars before the end of the year. We have already a couple of them in our page. So if you are interested, please go to our webpage. You will see you are seeing the address in the slide before, and join the webinars as you did with this one. So some practical issues, housekeeping before jumping into the webinar. Please write your questions in the chat. At the end of the presentation, the speaker will try to answer your questions if we have time. In this particular case, most probably this webinar will not last long, so around half an hour, so we'll have time for questions after that. I'm going to, before starting, a couple of questions just to check the main interest of the audience today, and to give some feedback to our speaker. So at the end of the webinar, you will have as well a small survey to answer, just to give us feedback and recommendations for future webinars. So let me go then to the 2 questions that I would like to ask you. There are a couple of questions, and there's one is about your particular profile. So let me launch the question. So the first question is just to let us know if you are more interested in technical aspects related to data and AI, or more in the business part of the business side of the application of big data and AI to your organizations. So you are seeing the question and you are also responding. So I give you a few more seconds just to get more or less the idea of the profile of the people attending. So a couple of more seconds, and I will give you the results. Okay, I'm closing now this poll. So just for you to know, is most of the people, 84%, are more interested in technical aspects, while 32% is in business related aspects. And the second and final question, let me launch the poll as well, is related to the subject of this particular topic. So is your organization applying deep learning today or different AI solutions, or is your organization providing solutions, AI solutions, or are you just interested on the subject, on the topic? So please, I give you a few seconds also to give you an overview of the type of audience that we have today. So one more second, and I close the poll now. Okay, so basically what you said is 25% is already applying deep learning in your organization, while 50% is developing AI solutions and deep learning, and 25% is basically interested on the topic. So that's the type of audience that we have today. Thank you for answering. So basically, now let me, without further delay, introduce today's speaker. We have the pleasure of having with us today Lara Lloret, which is a researcher at the Institute of Physics of the University of Cantabria, also belonging to the CSIC. Lara is working in the DEEP-HybridDataCloud project, and she is going to present an overview of their approach toward deep learning, as well as some interesting use cases that will showcase their approach. So without further delay, let me hand over to Lara. Lara, I'm giving you now presenting rights, so allow me to change the presentation. Okay, so Lara, you should have the control now. The floor is yours.
Okay, thanks a lot. Good morning, everybody. Thank you for coming to this webinar. As Thomas just told you, I'm going to tell you in this webinar about the DEEP-HybridDataCloud project and the different tools that we have been developing during these last months. So first of all, let's start, let's start with some definitions. So DEEP-HybridDataCloud, the deep in the name stands for deep as deep learning, but also is an acronym for designing and enabling infrastructures for intensive data processing in a hybrid data cloud. This is an Horizon 2020 project within an Infra 21 call, and we have started working on November the 1st already in 2017. We will be finishing this project next year in April. The global objective of the project, you can read it there, is to promote the use of intensive computing services by different research communities, ranging from biodiversity, cybersecurity, physics, and many more, and the support by the corresponding infrastructure providers and open source projects. You have there the web page of the project that you can visit. We try to have all the information centralized there, so feel free to visit it and check what we have. Now a bit of who we are. We are 9 academic partners, the ones that you can see there. 3 of them are in Spain, and 1 industrial partner, that is Atos. We are from 6 different countries: Spain, Italy, Poland, Germany, Czech Republic, and Slovakia. And let's now start directly with the focus of the project. So in the DEEP-HybridDataCloud project, or let me call it DEEP because it's shorter, we provide specialized cloud services to develop, exploit, and share machine learning applications. Of course, when I say machine learning, I mean also deep learning applications. We are right now covering the entire application development cycle. I will talk about it in the next slide a bit more in detail. And our main goal is to try to lower the entry barrier for people wanting to use this kind of technologies, these deep learning models, machine learning models. And for this, we are providing transparent access to specialized computing resources, such as accelerators and supercomputing systems. With this goal in mind, we have also built a catalog or marketplace. I will give you later all the information where you can find it and so forth. And there we are uploading the different applications and modules that we have been developing, and you can download them and use them in a very easy way. It's a very nice place in order to collaborate with your applications and to help you disseminate the knowledge by publishing your own model in this marketplace. So as I was telling you in the previous slide, we are covering right now the whole development cycle in machine learning. So as you know, because I have already seen your profiles, the development of a model starts in your PC or laptop. And first of all, we train the model using some data. Then we on the fly, we test it with some different, or validate it with some different data set. You know that this phase is the most resource consuming part because we need an adequate computing infrastructure, both in terms probably of storage to contain your full training data set, and also in terms of computing resources such as GPUs, for instance. Then, once this part is finished, you evaluate the model with the data that the model has never seen before, and then this cycle is going to be repeated until the evaluation is satisfactory. This last part of evaluation probably is not so important in terms of infrastructure. You can do it most of the time in your local PC, or you don't really need a lot of resources, but of course you can use them if you want. Once this cycle is repeated, as I said, till the accuracy you are getting is the one you want, the work can be published if you are in the academy. So for you can publish the architecture you have built, the data configuration, you can publish a scientific article, you can even upload the module in our marketplace or in a marketplace. Or if you are in the industry, you probably want to deploy it in production. So this is the whole cycle I was telling you about. But in all this description, there are some things that are open and that are a bit open for the user, right, to decide and probably problematic. So these kind of issues are the access to infrastructure, how to share and exchange the knowledge. Is there a standard way to deploy it as a production service? Which are the good practices, and many more that I'm sure you have experienced. So with all these questions, all these open questions in mind, the goal of our project is to develop a tool that we call DEEP as a service. So as I was already telling you in previous slide, and as you already know very well, training a machine learning, deep learning model is a very complex and intensive task. And it means that the user, in order to train this model, must have a full setup involving many things, such as hardware, the GPUs we were commenting about, for instance, or some storage system, the adequate drivers, dedicated software for it, and enough memory and well, storage resources. And very often, as we have experienced, the deep learning practitioner is not a computing expert. It's a person that wants to access to all of this technology in an accessible and transparent way, and just focus on creating a new model, and or even not even developing a new model, just applying a pre-built model to some data. And this is what we want to help with in our project by offering a framework for all users, not just for a few experts that really know how to handle this kind of setups, by enable the transparent training, sharing, and serving of deep learning models, both locally, as you will see later, I will show you some examples, or on a hybrid cloud system. And for this, what we are using, as you can imagine, are Docker containers. Our solution is based on these containers, where we package all the tools that are needed in order to deploy and run the deep learning models. As I said before, trying to have it as transparent as possible for a user that in principle is not a computer expert. The good thing here is that you don't need to worry about compatibility problems, because everything has already been packaged and encapsulated and tested, so that you can have a fully working model in just a few minutes. Using this kind of technology, as I said, allows you to package the entire application, include all the dependencies so you don't have to fight with them and you have no problems. And like this, you can avoid any compatibility issue or machine dependency that you may experience. So I was telling you before about the DEEP Open Catalog. This catalog provides an universal point for all the services offered by DEEP, all the different modules that we have. You have the link there. You can visit it and browse the different modules that we have. I will tell you about some of them in the next slides. In this marketplace, we had 3 different users in mind. So let me tell you how this user approach works. So basically, we have first the basic users that are people that probably are not very used to any of these deep learning models. They can just open the link of the marketplace, browse the different modules that we have, download some of them, and apply it to some local or remote data just for prediction. So they have an already trained model, they have some data, and they want to use a model that has been trained by some other people on their particular data. The intermediate user are users that can also browse the DEEP Open Catalog. They can also download the model, of course, also for prediction, but maybe they are more interested in doing some training using a module that has already some architecture, or that choosing and changing architectures is easy, and changing the parameters of the training is easy, and they want to train using their own data, but without much headache. But basically, they just want to have something like by default that works out of the box, and they can change just some of the parameters, but they don't have to enter into the tricky details of the development of one of these applications. And the final user can do all of the above, and of course, and in addition, they can also do more things. They can do more complex tasks, like, for instance, develop their own models from scratch. For this, we provide a framework for them in order to just be able to develop something on their own, and also to train, but including larger amounts of data. And for all of this, for all of these users, especially for the basic user and for the intermediate one, because probably the other user, the advanced user, they need even more than this, and we also provide it. But for the intermediate and the basic users, we have developed an API that is accessible from the web browser in order to make things easier, so that you can, as I said, from the web browser directly interact with your deep learning model. From this API, you can perform prediction on an already trained model. You can train on your own data, or check some metadata that comes with the model and that contains some information on how it was trained, or the contact persons, or all these kind of things. So let's see how this works. First of all, let me introduce you one of the use cases of the project. This is an external use case, because it was not one of the use cases included in the proposal of the project, but it was just a community from an institute in Belgium that had a problem. They saw our approach and they wanted to find a solution for it using our approach. So basically, they work this biological institute. They work taking samples of water in the North Sea, and they do so in order to check which is the content of phytoplankton that they can find there. So before the deep learning approach, they were just taking all this information, doing some processing, storing it in a database, and then some person by hand, a taxonomist, was checking which kind of phytoplankton they had in front of them. So what we have done is use our deep facilities, our deep tools, in order to perform the training on their database, and also to deploy the model as a service. So they can now do in an automatic way the classification of all of these images. And of course, in this case, was important not just to deploy it in the cloud, that of course is also useful, but especially important to be able to deploy it also locally, because sometimes they wanted in the boat without internet connection, they wanted to do some prediction on something for a quick test, and this is what we provided to them. So I just told you what the use case is about classifying phytoplankton images. It's a TensorFlow implementation using a network, a common network that is Exception. And let me show you how it looks like for a person that maybe is interested in this particular use case, or any other of the use case in our marketplace, and want to use it for prediction. So the first thing we have to do is to go to the marketplace. We browse all modules. Here you can see 4 of them. Just like that, there are more, and even more are going to come. Also generic use cases that can fit many different problems. But here are the ones you see here are more related with particular problems, particular communities that came to us, and we provide a solution. So you see there the phytoplankton classification. So if you click there, you will see something like what you see on the left. Well, some information, some tags, and also a link to GitHub, where you can have the code of the module that you are about to run, and also a link to Docker Hub when you have the access to the Docker that contains the module. So Also, next to this information, you have this other purple image that you see on your right. Well, for running it locally, that is the first example you're going to see, you need to have Docker installed in your computer, but this is no big issue. You have it for all different operating systems. It's very easy to install, and you can just download it, and in a couple of minutes, you will have it working. And you can copy these two lines into your command line. So one of them for retrieving the module to your computer, and there's the other line just to run this module in your computer. So once you have done so, you will be able to go to your web browser, localhost port 5000 in this case, that is the one we have indicated, and you will have something like what you are seeing there, an API endpoint for our DEEP as a service. So you have the possibility of return which are the models that you have loaded, because you can have more than one. You also have a place to check the metadata I was telling you about, another place where you can perform some prediction in case it's an already trained module, like in this case, and finally a place to train. So let's do some prediction, but first let's check the metadata. So if you click on metadata, you are going to get, for this particular use case, something like this: the version, the kind of module, the person you should talk with, the license, and some other things that that are useful for your module. Then if you want to start the prediction, you just click on the predict place, the predict button, and you will be directed to your own computer to check for the images you may have there. So I'm choosing a phytoplankton image. Once I have selected it, I can just click on predict, and I will be getting something like what you are seeing here. So I will be getting a response in the form that you can see here. I can download it as a JSON format so that it's easily integrated. It can be easily integrated with any other application that needs to access this result and perform some further calculation with it. And you see in the prediction, you are going to have a link to Google Images, also to Wikipedia in case it exists. It will tell you which type of phytoplankton it is. In this case, well, you see it in label. It says it's an artifact, and the probability is telling you which is the probability of this particular prediction to be accurate. That was all for prediction, and now we go for training. Imagine you want to train some for instance, image classification module. So again, we browse the marketplace. We see something like this. You have here some other modules different from the ones you saw before, just as illustration. But I invite you to check yourself in the link of the marketplace. So in this case, you could go to the DEEP-HybridDataCloud image classification. That is a generic image classification tool. And again, you will have something like this, where you will have a couple of lines. You just need to copy them, and immediately you will be able to open this API endpoint in your browser. And this is what you will see. This image on the right will be what you will see when you click on train. You can there indicate what are your images, different, I don't know, which is the kind of model that you want to use, the kind of architecture, if you want to use early stopping or not, if you want to use that augmentation, many other things, the number of epochs, all these kind of things you can modify from there. As I said, they are not very low-level features because this is for the intermediate user, but there are the typical features that one has to change for the first shots when performing a deep learning model. For the images, for this particular case, you just need to have all of them stored somewhere in your computer, and then have a text file indicating which is the path to the images and a number with the different categories. In this case, 2 categories, 0 and 1. And just with this, you will click on train, and your training will start. And after it has finished, of course, if you are running locally, this can be a problem if you have a big data set, but well, sometimes for small things, you can even do it in your laptop. When it has finished, you will be able to use the predict button, like what we have seen with the phytoplankton, and you will be immediately predicting, doing some inference on some data using the model that you have just trained. All of this was to run locally. That, as I said, in particular for cases like the phytoplankton, it was a nice approach because it's a feature that they needed to be able to run locally. But of course, you can also run in the cloud, as I was telling before. So for that, we have developed an orchestrator dashboard that you can connect into it. For the moment, this is just running in our project testbed, but if someone is interested in including some use case with the deep infrastructure, we can give access and you can check by yourself. Once you enter, you will see something like the image you see on your right, and you just click on the use case you are interested in. For instance, we have one for detecting diabetic retinopathy for the medical doctor. So you can just click on it, and once you click, you will be redirected here, where you will be seeing the status of your deployment. So once you have the status in create complete, that in general, if there is no problem, it will be in some seconds or just some minutes, you will be able then to access your endpoint, the API I was telling you about, the one that we were seeing in the web browser with the metadata training prediction. You will have an endpoint that you can now enter from your web browser, but instead of being running locally, as in the example before, you will be running in the cloud, meaning that you will have all the advantages of running the cloud, like for instance, in terms of storage, in terms of resources, and whatever you may be interested in. So you have seen here two examples on how to run locally and how to run in the cloud in a very transparent way, because again, the person doesn't need to worry much, just to select which is the module they want to run, and they will be able to access via the web API in a very transparent way. And finally, let me tell you about the EOSC Digital Innovation Hub. This established a mechanism to collaborate between private companies and also public research institutes and groups in order to access technological services, research data, and human capital. If you want to have more information on this, you can click on the link that you have in this page. DEEP and this Digital Innovation Hub, we have established a collaboration. DEEP is providing services to this innovation hub, and at the same time, this Digital Innovation Hub is looking for companies to conduct some application pilots. So basically, thanks to this Digital Innovation Hub and through the EOSC Hub project, you can all have access to resource providers. DEEP is included as a provider of the following services in this Digital Innovation Hub, the ones you can see there: machine learning application porting to EOSC technological infrastructure, machine learning implementation best practices, artificial intelligence enabled services prototyping in EOSC landscape. So these are the three services that we are actually offering in the Innovation Hub. You can see them again here, just for keeping them in mind. And within the Digital Innovation Hub, you can access to high performance computing services such as GPUs, HPC, for training deep learning applications, which means that it gives access to some infrastructure. You can also access to services for the automatic deployment of the models as a service, the DPaaS that you were seeing in the previous slide. And finally, you also have the possibility of publishing the applications in the project catalog that can have a great impact and improve the visibility of your application. And it is possible to grant the sponsor access to the resources. So if you are interested in this, I will give you some mail addresses at the end, and you can contact us, and we will give you all the information on how to proceed if you are interested in having this access to our resources. So in conclusion, the DEEP project offers a user-friendly entry point and a set of open tools in order to take advantage of the latest deep learning, machine learning machinery in an easy and transparent way. We are a machine learning service provider at the EOSC, and we cover all the steps of the machine learning application development cycle. We have tools for federated learning, ensuring integrity, privacy, reliability, insurance, auditability, and traceability. And we also offer great possibilities for the exploitation by companies through the EOSC Innovation Hub, like for instance, development of a pilot. We give the possibility of access to computing and storage resources that can be sponsored again through the pilot, and also the possibility of technical support. And also we are providing some help with the visibility and the publicity and dissemination of the results using our marketplace. So this is everything I wanted to tell you, but I put here some references, the contact of the project coordinator and my own contact, and also the general DEEP mailing list contact. You feel free to write to us anything that has that interests you or anything you may want to ask. Please feel free to contact us at any time. Also, you can find here the web page, our social media, well, right now, Twitter, the open catalog. I already gave you the link before. You have it also here. All the documentation, since you are more interested in the technical part, you can take a look at the documentation. And finally, a YouTube channel where we have included many different demos of different possibilities that you have using our tools. So I invite you to go there to check what we have and try to play around with the different tools that we have to offer. So that was all on my side. Thanks a lot for the attention.
Thank you, Lara. This has been very interesting. As I mentioned at the beginning, you are free, the people that are attending to the webinar, to put questions on the chat. So if you would like to ask any question to Lara now, you are free to write it there. I see that there is one. Let me check. No, it's not a question. This is someone that has problem with the audio. But I have a question in the meantime. If because you mentioned at the beginning that you are following this containerization approach using Docker for the models, but are you providing also some Dockers for with some AI solutions, not only the models, but like places where you have, for instance, TensorFlow or Jupyter notebooks for deploying in our own infrastructure and trying to create our own models, or you are only providing Dockers with the existing models that you have?
No, that's a very nice question. That is what I have shown is more for the basic users and for the intermediate users that we are already giving some pre-built models, but we also give Dockers where you have everything installed, and then you have a Jupyter Lab, and that you can access also from the web browser in the same way as we were accessing the API. And from there, you can work directly on the terminal or directly on the Jupyter node on your own model and develop it from scratch. So basically, as you said, a place where you have all the typical modules that you're going to need in order to develop your model, but instead of doing it locally, you can use our tools and develop it directly on the cloud.
Okay, that's very interesting. I have also another question, because I found this very interesting, this approach of giving the possibility of accessing to your resources via this digital innovation hub. I think it's quite interesting. So, for instance, if you're in a company or you're working in another European project that is using the deep learning also, is it possible to apply somehow for the use of your models via this in Digital Innovation Hub, and also having some resources, for instance, for training the models that you are deploying in a specific European project, or this is something that is not entirely clear?
No, it's possible, and if you're interested in that, as I said, you can write a mail to us. We can provide access to computing and storage resources, even technical support, and everything will be sponsored through a pilot that we can do for your application. So that's completely possible. I cannot give you exactly the steps that you have to give in order to do this. If you write to us, I will send you all the information, and of course it is possible to do it both for companies and for public research groups.
Okay, that's very interesting. So I don't have any more questions, and I see that there's no specific questions so far. Yeah, there is also people asking where we can where will be available the slides. The slides, as I mentioned at the beginning, will be available via the webinars page from the BDVe. So let me show one moment in the screen. Let me take again my control of the screen just to show the URL again for all of you. 1 second. So you are probably seeing now my screen, and the URL at the bottom of the screen is where you can find not only this webinar, but all the webinars that we are running, and also the slides will be available there, if not today, tomorrow. There is another question also on the chat. For instance, people are asking if do you have examples of usage by industry with confidential or private data? How could SMEs, for instance, or startups benefit of your platform?
So right now we still don't have this kind of modules because we have been working mostly with research, public research groups, but we are going to provide these services. So stay tuned to it. And of course, if you are interested in a particular use case, write to us, and we will inform you on if these kind of solutions are good for your company, and that's what you are looking for.
Okay. There are more questions now. So, for instance, someone is asking, as for federated learning, what kind of implementation has been developed? Is it possible to join as a worker or peer in this federated system?
Yes, it is possible, but again, it has to go via one of these, for instance, the Innovation Hub. We have to develop a pilot together there, and then you will have access to these kind of tools.
Okay, one more question is related to the sustainability of the marketplace. So do you have plans for once the project ends to make it sustainable?
So yeah, after the project ends, we plan to make it sustainable and to still be offering the modules there. And the ones that we have now, and even more that are going to come in the future, in the next future. So yeah.
Mm-hmm. Another question is related to the models and services that you're providing, and is asking if you are interested also in providing NLP modules and services.
Yeah, we have already some of them. We have one for speech to text and speech recognition, but we are interested in general in any deep learning module that can be integrated in our infrastructure. We are happy to help and to provide the tools needed.
Okay, so I think there's no more questions so far. So thank you very much, Lara. I think it has been a very interesting presentation, and also I like very much the idea of having a digital innovation hub where you can provide your services through them, because I think it's a very interesting approach. And yeah, and I thank you all the attendees as well for the questions. And as I mentioned before, you have the possibility of accessing to this presentation and the recording probably at the end of today or tomorrow via this URL that is at the bottom of the page. So it's the Big Data Value.eu resources webinar. In there, you can see not only this one, but also the previous webinars that we have been running for more than 1 year now. and also the links to register to the new ones. There will be new ones in December and the end of November, as I mentioned before, and more coming in the next year. And nothing else from my side. So thank you very much again, Lara. Thank you to everybody.
Thank you.
And stay tuned with the next webinars. Thank you very much. Bye-bye.
Bye.